Welcome back. We are on lesson 5. So we are going to skip this do now. Don't even take a look at it. It's harder than you will ever have to do. That's why I'm just going right past it. We'll get to the lesson, which is about cofunctions. So we'll kind of talk about what those mean, what they are. So we'll take a look at this where it says given the right triangle below, we have two acute angles, 37 degrees and 53 degrees. And it's asking us to find the ratio, determine the ratio for each of these. So we'll go ahead and quickly do that. So sine of 37 degrees. So 37 degrees. Here's opposite, adjacent, hypotenuse. So sine, I'll just real quick write out SOHCAHTOA here. Sine is opposite over hypotenuse, so 6/10. You can reduce that if you want. I'm just going to leave it. I'm also going to take care of cosine of 37 since it's from the perspective of the same angle. So that's adjacent over hypotenuse, which is also 8/10. Okay, so we're going to change now our angle. We're going to look at it from 53 degrees. So if we look at it from 53 degrees, 6 is the adjacent and 8 is now the opposite. So sine of 53 would be 8/10, and I should say cosine. And the cosine of 53 should also be, should be 6/10. Okay, so we notice something here that kind of happens. We're seeing that sine of 53 and cosine of 37 are equal. Sine of 37 and cosine of 53 are equal ratios. Let's take a look at it with general, just like kind of letters, not putting in any sort of numbers here. So we're going to determine the value for sine of angle A, sine of angle B, cosine of angle A, and cosine of angle B. So sine of angle A. I'm not a fan of that green color, so let's do a nice blue. So we're going to label opposite, adjacent, and hypotenuse. So opposite angle A is side A, opposite angle B is side B, opposite angle C is side C. So sine of angle A would be opposite over hypotenuse. So A over C. Cosine of angle A is adjacent over hypotenuse, so B over C. If we're looking at it from angle B though, then this is the adjacent and this is the opposite. The hypotenuse stays as the hypotenuse. So the sine of angle B is opposite, so now that's B over hypotenuse, so C. Cosine of angle B is adjacent over hypotenuse, so A over C. So what we're seeing here is sine of angle A equals cosine of angle B, and sine of angle B equals cosine of angle A. That should make sense because when we change the perspective of our angle, the opposite and the adjacent start to, kind of switch. So what can we conclude from these results? We can conclude that sine of angle A equals cosine of angle B, and sine of angle B equals cosine of angle A. If we look back up here, sine of 37 equals cosine of 53, sine of 53 equals cosine of 37. I want you to notice something about kind of like these angles, 37 and 53. When you add them up, they add up to 90 degrees, and that's important. Sine and cosine are what we call cofunctions. for complementary angles A and B, if two angles are complementary, so 37 and 53 are complementary because they add up to 90 degrees. So if you have two complementary angles, like 37 and 53, cosine of 37 is going to equal sine of 53, or sine of A equals cosine of B. And this is kind of showing it in like your math notation. Okay. The co-prefix in cosine is a reference that cosine is an angle. Cosine of an angle is the sine of its complement. So I don't know if you ever realize that kind of sine is right there in cosine. So it's telling you that cosine is the complement of sine. So the big thing to take out of this is sine and cosine are cofunctions. Sine and cosine are cofunctions, and their ratios are equal when their angles add to 90. So that's kind of really important, and maybe we want to just kind of write that down. Okay, so sine and cosine are cofunctions. Their ratios are equal when the angles add to 90 degrees. So that's going to be important, especially when there's questions that we have to explain our reasoning, explaining our answers. So let's take a look at a couple of questions here. I'm seeing everything sine, cosine, and they're saying they're all equal. Remember, sine and cosine are cofunctions, and their ratios are equal when their angles add to 90 degrees. Okay, so I'm just going to leave that there because that's like really, really important. So we need to kind of think about what value would make these equal. Well, sine and cosine, they're cofunctions, so they're going to be equal when their angles add up to 90 degrees. So we could set up an equation. If you can't see that it's 25, we could always say theta plus 65 needs to equal 90. And we solve it out. Theta equals 25. So I want to go over to the calculator and just show you that. Because you could always check this too. So if I take a look and I evaluate sine of 25, the calculator is going to take a look at an angle that's 25 degrees, and it's going to give me the ratio of that, so 0.422. So now if I go ahead and do cosine of 65, it's also going to be 0.422. They are equal. Let's look at this next one. So once again, we're dealing with sine and cosine. They're going to be equal. The ratios are equal when their angles add to 90. So we can set up an equation. 80 plus theta has to equal 90 degrees in order for these sine and cosine functions to be equal. So theta has to equal 10. Let's go ahead and just put that in and check it out. So sine of 80, okay. Cosine of 10, okay. So they are equal. Their ratios are equal since their angles add to 90. All right, we'll take a look at this one. They're telling us these two functions are equal. So let's go ahead and say, all right, well, they're going to be equal if this angle and this angle add up to 90 degrees. So now we have an equation that we could set up. So we could say theta plus 10 has to equal 90 degrees in order for them to be equal. So 2 theta plus 10 equals 90. 2 theta equals 80. Theta equals 40. So take a moment, you can pause the video and check, substitute back in and do sine of 40 in the calculator, see if it equals cosine of 50, and it does. Then our last one, again, we're going to set these two angles equal to 90 degrees because they're telling us sine and cosine are equal. They're equal when their angles add to 90. So theta minus 45 plus theta equals 90 degrees. Solve it out. 2 theta minus 45 equals 90. to theta equals 135. Go ahead and divide that out. 135 divided by 2, and 67.5. Okay. So in scaling triangle ABC shown in the diagram below, which equation is always true? Okay. Sine of A equals sine of B. Well, I'm gonna label these in general terms. I'm gonna say this is side C, this is side A, this is side B. Opposite angle A is side A, opposite angle B is side B, opposite angle C is side C. So we kind of go through this. Sine of A, that's opposite over hypotenuse, so that's A over C. Is that equal to sine of B? Sine of B is opposite over hypotenuse, so that doesn't equal B over C, so it's not that one. Look at choice 2, cosine of A, adjacent over hypotenuse. Does that equal cosine of B, adjacent over hypotenuse? No, that's wrong. Cosine of A equals sine of C. Okay, that's not going to even work because we can't do opposite adjacent hypotenuse because we're doing it of the right angle. So let's look at this one. Sine of A right here, opposite over hypotenuse, A over C. Cosine of B, that's adjacent over hypotenuse, that's also A over C. So it's choice 4. And the reason why another way we can think about this too is this is a right triangle, meaning we've used 90 degrees. So left over, we only have 90 degrees left over. These two angles added together, A and B, angle A, so the measure of angle A plus the measure of angle B has to equal 90 degrees. So sine and cosine are cofunctions. They are equal when their angles add to 90 degrees. The A and B just have to add to 90. Which expression is always equivalent to sine of x? Okay. So I'm seeing all cosines. So sine of x equals cosine of what? Well, sine and cosine are equal when their angles add to 90. Let's just play this out and pick an angle for x. So say I made it sine of 20 degrees. It's going to be equal to cosine of 70 degrees. Well, how do I get 70? I get 70 by doing 90 minus 20. So replacing 20 back with x, it's going to be 90 minus x. Okay. Find the value of r that will make the equation sine of 73 equals cosine of r true. Sine and cosine, they are equal. Their ratios are equal when their angles add to 90 degrees. So r has to equal 17 degrees. So now we need an explanation here. Well, the explanation is going to be exactly what we kind of talked about earlier. This is going to be almost like your explanation every time. Sine and cosine are cofunctions. Their ratios are equal when, I'm going to just do, their angles add to 90 degrees. That's going to be your standard explanation. Sine and cosine are cofunctions. Their ratios are equal when their angles add to 90. Okay, for 5, we have triangle ABC. C is a right angle. I'm just going to draw that out real quick. Okay, so C is a right angle. A, B, C. What is sine of B? So cosine of A, sine of B. There's a couple ways you can think about it. Since we've used 90 degrees already, we only have 90 degrees left over for A and B. So that means A and B added together, the measure of angle A plus the measure of angle B has to equal 90 degrees. So cosine of A, sine of B have to be equal. Their ratios, this is cosine's ratio, that has to be the same as sine's ratio. Because sine and cosine are cofunctions, and their ratios are equal when their angles add to 90 degrees. So that's one way to do it. The other way is cosine of A. So we're at angle A. Cosine is adjacent over hypotenuse. So the adjacent is radical 21, the hypotenuse is 5. If we want to find sine of B, well, now we're over here. Sine is opposite over hypotenuse. This is the opposite, this is the hypotenuse when we're looking at it from angle B. So that's another way you could think about it. Okay, and our last one that I'll do with you. So given right triangle ABC with right angle C, if sine of A increases, so the ratio sine of A, if all of sine of A increases, then what happens with cosine of B? Well, sine of A and cosine of B, sine of A and cosine of B have to be equal. They're equal because sine and cosine are cofunctions and their ratios are equal when their angles add up to 90 degrees. A and B have to add up to 90 degrees. That's another case right here. A and B have to add up to 90 degrees. So our explanation is going to be that standard explanation. Okay, so here's our explain part. So the answer is increase. If sine of A increases, then cosine of B also has to increase because they're equal. And the explanation is sine and cosine are cofunctions. Their ratios are equal when their angles add to 90 degrees. And we know that A and B have to add to 90 degrees because we're looking at a right triangle. Okay? So why don't you take a moment, and there's some practice questions, I think just 3 of them. So pause the video, try those right now, and I'll post the answers after you unpause it. And here are your answers for the 3 practice questions. Common mistake probably in question 2, setting A plus 15 equal to 2A. The angles aren't equal, their ratios are equal. So the ratio of sine of A plus 15 equals the ratio of cosine of 2A, or alpha, I guess. So you need to add, they're equal when the angles, when this angle plus this angle adds to 90 degrees. Okay, so then you solve that out and you get 25, and then 3, pretty standard. Sine of A must equal cosine of B, so it also equals 5/13. So you have your additional homework assignment. Make sure you're submitting that. Try to please do it before 5 p.m. so I could take attendance. If you have any issues, as always, you can email me.